Hello everyone, welcome back to my channel. I am Sakshi and here is the episode 9 of Learn DSA with Sakshi. In today's session, we are going to learn the singly circular linked list, one of the most important type of linked list in the data structure. We will be covering all 8 core functions of this list one by one with easy understand logic and then code implementation and simple diagrams to visualize the each steps. Now, before we begin, I want to tell you something important. If you already understood the singly linear linked list, then this topic will be super easy for you. And that's the reason we took time earlier to understand and build the complete singly linear linked list program. And because of the logic we are going to use here is almost the same with just small one twist. And the twist is that in singly circular linked list, the last node doesn't point to the null. Instead, it points back to the first node, forming a closed circle. And that's it. With this small change, we create a powerful and continuous structure that we can traverse infinitely. So let's get started and understand this list one function at a time. And by the end of this video, you will be confident in working with the singly circular linked list. So let's begin it. So what is the singly circular linked list? SCLL. In this type of linked list, the last node of the linked list will hold the address of the first node, and due to which the type of linked list is called as a circular linked list. As the last node is connected to the first node, it forms a complete circle, and so that's why it is a circular linked list. And as this type of linked list is circular, the traversal mechanism is totally different from those of the linear linked list. And as it is a singly circular linked list, but it is a singly, not doubly. So the address it contains address of the next node only. And due to the circular nature, we have to maintain two pointers. One is pointing to the first node and the other will point to the last node. So this is all about the singly circular linked list. Then here are the key components of the singly circular linked list. Three components are first is node, second is the head pointer, and third is a tail pointer as discussed. Node you can store the value of the node, so that is the data, and in next pointer it points the next node in the list. Then head pointer, it points the first nodes in the list, and then tail pointer points to the last node in the list, which links back to the first head. If you can remember, then we saw in the singly linear linked list, we had only one pointer, and that is the head pointer, right? And similarly, in the doubly linked list, we had the head pointer, and in the node structure, we have next and previous pointer. But in singly circular linked list, in node, we have only data and next pointer, and then head pointer for pointing to the first node, and tail pointer to point at the last node. So this is all about the singly linear linked list. Now let's actually implement it. So without wasting much more time, let's begin with the VS Code. So open your VS Code. So open your VS Code. So let's create a one new file and name it as program14.c and comment it as singly circular linked list. Now we'll write the code from scratch so that you will understand it. If you don't understand the code of the singly linear linked list or say doubly linear linked list, then this will be the type of revision for you. So let's begin with the first. We will write its basic structure, and then we'll be implementing its logic one by one. So starting with the header file. So include our two header file. Then second is hashtag include stdlib. lib.h. Then we write the node structure and then its type def. It is same as all in this all linked list program. So struct node, then int data. Its node has two members. One is the data and second is the next pointer. So struct node start next, only next, as it is singly circular, so it requires only next pointer. It doesn't require any previous pointer. Then semicolon. Then our type def structure. Type def struct node. Then type def struct node star node. I hope you remember why we use struct date and why node structure is like this. Then type def struct node star star pp node. So here is the type def. Now we are going to write the first eight functions basic structure. So our first function is insert first. Insert first, and we'll see its parameter later. Then second is insert last. Then we have, let's say, display first, void display. Then int count. Then void insert at position. Then three delete functions. So first is delete first. Then delete last. And last is the delete at position. At position. So these are the eight functions, and we will see it one by one. Now write the main function, return 0. So this is the basic structure of our code. Every time we write this, and then we will see logic of each function one by one. So it will be easy to remember you. If you once know how its structure is, then you just need to simply write its logic. So now let's begin with the insert first. So let's write the parameter of the insert first. So pp node height, then int number. Now tell me if we require any other parameter here. As it is the singly circular linked list, we need to connect the last end of the linked list to the first end, and so that we discuss the tail pointer. So we need to use it here also. So it will be pp node tail, right? So we require three parameters for this. Now let's see how to implement it. Now, firstly, we will allocating memory to the new node, then assign value to the number and the data, and initially then set the pointer of the new node to null. And if the list, then we saw the conditions. If the list is empty, then we will handle that case, and then we'll set the head to the new node. And since the if the list has only one node, then what to do with the tail pointer, we will see that. And in the last case, if it is at multiple nodes. So in this way, this will be the flow of this function. So let's write it. P node new n is equal to P node, then malloc size of nodes, then new n data is equal to number, and new n next is equal to null. New n next is equal to initialize to null. Now we are checking if the list is empty or not. So it is just like the previous code, but its condition will be different because it consists of not only head but also tail pointer. So first condition is if star head equal to null, means if first is null, and we need to check also the last condition. If both will be true, then and then only we'll proceed to the further part. So for that we need to use the AND operator. So give it a bracket here, then and star tail equal to null, means if the first and last is null, means it has this link has no node. So means the list is empty, so set head to the new node. So star head is equal to new n, and then star tail also equal to new n. We'll see diagram, don't worry. So this is about the if part, and then else part means if it is empty, when we'll do this. If it is not empty, then just make the new node next is equal to star head, and then star head equal to new n. Star head is equal to new n, just like the previous linked list. And now we need to add one more statement, which is for the connecting last node to the first node. And for that, star tail next is equal to star head. Star head. So set tails next to head to maintain the circular link. So this is the code of the linked list. Now we'll see its diagram. Let's quickly understand this logic one more time. Firstly, we are inserting new node, so allocating memory to it, then data and next to it. And now we are checking the two condition, if the list is empty or not. If the list is empty means if star head and star tail, as it is circular linked list, it has head and tail also. So we need to check both the conditions. So for this we are checking if star head equal to null and star tail equal to null. If the list is empty, then this new node will be both the head and the tail. So star head equal to new n means now head now points to the new node and tail also points to the same node. So if the list is empty, then this is how we are inserting the first node. Else means if the list is not empty, if the list is not empty, then point new node to the current node. So new node point to the current node and then update the head to point this new node address. Firstly, it will hold the address of the first node before inserting it, and at the end to maintain the circularity means when this if part means whether it is empty or not when we are inserting in, this is important to maintain the circularity. So the last node means tail should be point back to the new head to form a circular list. Now let's see its diagram. So let's say I want to insert first. I want to insert 5 at the position first. So before that this is not there means I so before inserting our linked list is just like 100, 10, 20 and 30. Now I have to insert 5 at the position first. So for this means now our linked list is not empty. So it is checking the second condition else part, right? So now we are making the new node. So say this is our new node, right? It has data and the next pointer. Initially next pointer is null, right? Here is our code. Now what else part said? Make new and next equal to star head. So this is new n and this is new n next 200, right? Now it is 200, but how it comes 200? I am just understanding this to you. So this is new n next and it is pointed to star head. Now before inserting this first, our star head is this, right? So make new n next equal to star head. So this is how we connecting this, right? Then what it says that star head equal to new n. Now our star head this and it point to the new n. New n is this. So now this is how this arrow is linked with this node. For more clear understanding, I have shown the arrow in the red color. So first this is formed, then this will be formed. So number 2. And at the end, to maintain the circularity, what we have done, we have connected tails next. So this is tail next and it is connected to the star head. So in this way, and this is the third step. So in this way, we form a singly circular linked list connecting tail to the head and inserting first. So in this way, we insert first. Now let's move to the insert last. If you understand the insert first logic, then insert last will be easy for you. So let's write it. Its parameter is same as the insert first of this linked list. So pp node head, pp node tail, and at the end integer number. Now firstly, we with the help of malloc allocating memory for the new node. So write p node new n is equal to p node, then malloc size of node. Uh, Type it correctly, otherwise it will give you error. Then allocating data and next pointer to the new node. So data, which is equal to number, and new and next initialize to null. Now we are checking the two conditions just like the insert first. If it is empty or not. If it is empty, then do this. Otherwise, go to the else part. If it is empty, how to check it's empty or not? If both head and tail is are null, it means that our list is empty. So for this, write star head equal to null and star tail equal to null. Star head equal to null and both should be true, then and then only our list is empty. So star head equal to null and star tail equal to null. If this, then make star head equal to new n. Now it contains one node and which has head. As it is a circular linked list, it tail should also point to the new node because it has only one node. So that's why head and tail point to the same node. Then if condition is over, then go to the else part. If it has more than one node, means if our list is not empty, then update the next pointer to the current tail and then point it to the new node, and then we'll move the tail pointer to the new node and then ensure tail's next pointer point to the head to maintain circularity. So for this, just write star tail next is equal to new n, which means we are inserting in the last. And now making star tail is equal to just updating star tail, right? And just maintain the circularity. Star tail next is equal to star head. So this is how insert last work. Let's see its diagram in the same diagram of the insert first. According our code, so star tail next is equal to new n. So new node will be here, and then we are updating star tail. Firstly, it is the tail. Now tail will be this, and then we are connecting this to the first pointer. This is how it will look like. I hope you understand both the insert first and insert last. Now let's move to the next function, that is the display function. Here I have already written it. So for the display function, our parameter will be pnode head and pnode tail because it is a call by value function. So that's why we are not using the ppnode head and ppnode tail. So the flow of this function is like, first we are in if condition, first we are checking if our linked list is empty or not. If it is empty, just print the message that the list is empty and simply return from it. So how we are checking it is empty or not? By just simply writing head equal to null and tail equal to null. If both are null, means our list is empty. So print message and return from it. If the linked list is not empty, then we are first displaying this message that the elements of linked list are. And then in the circular linked list, we are using or prefer to do while loop instead of the while loop. Why? Because when we try to traverse this list, if we write simply while loop and give condition like temp is not equal to head, this means when it's checked, means on the first check, temp is already pointing to head, right? So the loop will not run and the first node will get printed. Means just see the example. If our linked list has 10, 20, 30, 30 is the last node, so 30 will point toward the 10. So which is our head first. So in the first check itself, temp is already pointing to head, so it will not print the first element. So that's why we are not using while loop here. So we are going with the do while loop. So when we use the do while loop, it prints the first node. It prints the first node before checking the condition. Because do while loop execute one time once if the condition is false, right? Means whether condition is true or false, whether it's means it will print the first iteration. So that's why we are using the do while loop. Means in simple words, we can say that in circular linked list there is no null, so we don't use the while loop. And as the last node is linked with the first node, and if we don't print the first node before checking, we'll skip it completely, and we don't want it. We want whole linked list to be displayed. So that's why we write this condition. And in the print statement, we write heads data and then update head is equal to head next. And in the while condition, whenever or up till when head is not equal to tails next, means up till means until it's not iterate to the last node, it will keep printing. And when tail is equal to tail head is equal to tail next, it will stop printing and come to the next line. So this is how display function works. Now just quickly see the count function. Again, counts function parameter will be p node head and p node tail. So quickly write it, p node tail. Then firstly, we'll initialize the counter to 0, then checking list is empty or not. Then we'll start from the head node, then traverse the list, and for each node, increment the counter, and we'll move to the next node. And we'll stop when we circle back to the first node, means head node, and then return the final count. So just write it that first take point variable, that is count, and initialize it to 0. It is I count equal to 0, then checking it is empty or not. For that, head equal to null, and if tail tail equal to null, simply return, or you can display message also, message and return from it. Then again we are using the do while loop here. So firstly, I count means increment the counter, then head is equal to head next, means we are updating the head pointer, and in the and what is the condition here? Simply until when head is not equal to tails next. So tail next, till then there should not be gap between these two. Till then, count the means increment the counter, and when it stops, simply return the count. Return I count. So this is how we write the count function. So now let's move at the insert position function, and then we'll see the three display delete function. So what will be the parameters for the insert position function? So first will be pp node head, then pp node tail, then number means which we want to insert, and the position where we want to insert that number. So now the interesting part is that logic of the insert at position in singly circular linked list and singly linear linked list is same. You just need to add the tail pointer and that's all. So isn't it interesting? So you don't need to remember this logic if you are able to remember or understand the logic of the singly linear linked list. Now we are just copying that code. Here is the logic, and just paste it here. It is IPOS. Now we just need to add our tail pointer here. So first is inode 0, means total count is 0. Then we'll take one variable. Then we node new and temp is both are initialized to null, both pointer. Now we are count node is equal to we are calling the count function. Now as the parameter of the count function is head and tail, so just write star tail also. Right, then we are checking means the position is valid or not. If it is less than 1, it is invalid. Similarly, if it is more than the nodes, then it is not be valid. So checking it, and then three condition: if the position is 1, then call the insert first, and if the position is last, then call the insert last function. Here it is giving error because insert first parameters are the pp node head, tail, and int number, and we have given only two parameters. So just add tail here. Similarly, add here also, and give it in the sequence, means first head, tail, and number. So this is how, if the condition is first or if it is last. And here comes the else part, means if the condition is in between the position. So allocate a new memory for the new node, then its data, and next pointer initialize it to null. Then in the temporary pointer, hold the address of the first node. Then we use for loop starting from the first position, and it will go the towards until IPOS -1, and when it go inside the for loop, just update the temp pointer, that is temp equal to temp next, and then increment the counter. And when the for loop function is completed, then it will print new and next is equal to temp next and temp next equal to new and. This whole logic is same as our singly linear linked list logic. So no need to change it here. Everything will look like this. So this is all about the insert at position function. Just you need to add the tail pointer here. Now we'll see its diagram, how this else part actually working. And now here is the diagram of the insert at position function. So I want to insert the 75 at the fourth position. So this is the first position, second, third, and between the third and fourth, I want to insert this 75 node, right? So it is as you can see, it is a circular linked list. Now we just simply need to cut this part, means cut this and then link these two nodes. So how to do this? So as I want to insert at the fourth position, so it will go in the else part directly, right? Because first is of the insert first, then insert last, then insert at anywhere between the position. So this is the new node, its data and its null, right? Now we are making temp equal to star head. So when I is equal to, means when we go inside the for loop, for I is equal to 1, when I is our 1, when I is our 1, I is less than 4 minus 1, 3. So it is go inside the loop and temp is equal to temp next. So first is 100, then I plus plus. When I is equal to 2, then it will print, it will point to the 200. And similarly, when I is 3, it will point to 300, right? So 100, 200, and 300. Now for loop function completes here. Then after that, whatever code says that new and next is equal to temp next. So this is new and next is equal to temp next. Our temp is 300, temp next is 400. So now this will point to this like this, right? And then what say temp next is equal to new one. So temp, this is temp next, and it will point to temps next equal to new one, and in this way, this is removed. I just bold the arrow so to get you clear. So with just two statement, we unlink this link and link this new link. So now linked list will be 11, 21, 51, 75, 101, and 111, and 111 will hold our first address. Last node address is 100 instead of 600. In the previous diagram, I mistakenly wrote 600 here. So just correct it. It will be 100 as it take the address of the first node, that is star tail equal to tail is equal to star head. That's it. Then now let's see this delete first, then last, and then inserting at the position. So just quickly see the delete first. Its parameter will be pp node head and tail only. pp node head and pp node tail. No need to add number because just want to delete the number which is already present. So first we are checking if the list is empty or not. Then if it is empty, return from it. Then checking if it is contain simple node or multiple node. So just write if star head equal to null, and star tail equal to null. If means if the list is empty, return from it. Else if means if there is only one node. And how we get to know that it contains one node or not? For this, the condition is if star head equal to star tail. Means if both address of the head and tail is same, then it will contain only one node. So how to handle that case? If it contain one node, just delete that node, means free. I am writing free star head here, and after free the single node, just set both tail and head to null as the list is now empty. Now just write star head and star tail equal to null. So star head is equal to null and star tail also equal to null. So this is about the else part. Now if it is contain more than one node, or if the list is not empty containing multiple nodes, then temporarily store the head node to the head node to free clutter. So p node temp is equal to star head, then star head is equal to star head next. Star head next means move the head pointer to the next node. This is how we are moving the head pointer to next, and then free the old head node and then update it. How to free? Just write free old node, that is temp, right? Free temp and then update the tail pointer. So star tail next, star tail next is equal to star head. Update the tail's next pointer to point to the new head. So maintaining the circular structure. So this is how delete first works. Firstly, checking it is empty or not. If it is empty, return. If it is contain single node, then free that node and make head and tail equal to null. And if it is contain multiple node, just first take a temporary variable to store the address of the first node. Then moving toward the next node, then free the old node and just maintain the circularity. So this is how delete first is work. It is very simple, right? Now let's move to the delete last. Now let's see the delete class. Again, its parameter is same as the delete first. So people node head and people node tail. Then first check if the list is empty or not. For that, star head equal to null and star tail equal to null. And if it is empty, just return from it, as there is no node to delete anything. Else if it contains only one node, means if star head equal to star tail. In this case, free that node, free that single node means free star head. And then as the node is free now, then make head and tail equal to null. Means there is no node. We delete that node. It's equal to null. So this is about the else. And if the list contains multiple nodes and then we want to delete the last node, then firstly we need to temporarily store the address of the first. So for that, I'm taking one pointer, that is temp, and it is equal to the star head. Then in while loop, just write temp next is not equal to star head. Then update your temp as temp next. It means we traverse the list until reaching toward the last second node. So this is what this loop means traverse the list until you reach the last second node. So when we reach there, then temp next is equal to star head and then free that temporary means free the last node. Temp equal to temp next. When the while loop stops, we get the last second node. Now temp next means temp next will be last. So free the tail and then just start tail equal to temp. Start tail updating term. Means set the second last node next pointer to the head to maintain the circularity. Temp next equal to star head to maintain the circularity. Then we free the last node. The last node is star tail. And then move the tail pointer to the second last node. Second last node, that is temp. So in this way, we can delete the last node of the list. So isn't it simple? Now let's see the last function, and which is nothing but the deleted position. So again, what will be the parameters? First is pp node head, then pp node tail, and IPOS in IPOS. Now this logic is also right, and there is one more logic, and I think this will be very easy rather than this. So mm, when just 1 second. Yeah, in the else part, p node temp is equal to star head. So just update these three lines, and we can write first we will free the temp next. As temp is the second last node, we are free its next node. So free this, then start till is equal to temp, right? Now last, as the last node is deleted, temp will be start till, and then start till next is equal to start get. As we follow this logic in upper code, so I thought it is prefer than this. So just like this. Now moving toward the delete at position, we are writing its parameter as head, tail, and IPOS. Now just write and count mode. Again, we can, if you can remember, we took the insert at position program of the singly linear linked list and just update the tail part there. So similarly, we can take this part and just update this. So this reduces our time. Now just copy paste it. And so let's see. First for the total number of nodes, then one variable, then taking two variable temp and target, initialize it to null, then calling our count function and give its parameter as start tail also because it has head and tail parameter. Then filter means the position is valid or not. Then as we want to delete the last node, so it should be less than the count node, total number of nodes. Then if the position is first, then delete first. We'll call delete first and also update it here as it takes tail also. And if it is the last node, then call the delete last. And if the else part, we are taking one more pointer, temporary store address of the first node, then for loop to go at the required position means if you want to insert at 3, so it will take up to your second position. Then target equal to temp next and temp next equal to target next, and at the end free that target. So this logic is same as of the singly linear logic. So in this way we write the whole code of the singly circular linked list. Now just save the program. As the video is already lengthy, I'm just pasting this part. So here is the main part. Just like the first, call p node last equal to null, and then I have to insert first 51, 11, sorry 21 and 11. And similarly here are the insert last call, then display, and after that I'm inserting 75 at fourth position and then display. So this is the main part. You can type it later. So here is the code for that. You will do it later. Now just open your command prompt and let's see it is working or not. So first save the program. So here is the command prompt and go to your directory. I already in my directory. Then gcc your program name, as our program is 14. So 14.c minus o and my exe. Then my exe.exe. And here is the output. So first is this part means first 11, 21, 51, and then at the end we insert 101, 111, and 121. And this arrow means it is linking to the first node. As we can't able to show it in circular manner, we give this arrow. And total count of the linked list is 6. So this is about the first display. Then what we do, we have insert 75 at the fourth position. So let's see it's correct or not. Now this is for the second display. So first, second, third, and fourth. Yeah, it is showing 75 at the fourth position, and now the count is 7. Then delete position and then call. So last display function is this. Now we want to delete that 75 and then return the count. So see 75 is deleted from the fourth position, and now the number of elements are 6. So in this way we complete our singly circular linked list. I hope you understand this video. So that's it for today's video. We covered all the important functions of the singly circular linked list along with the step-by-step logic explanation and simple diagrams. If you have already understood the singly linear linked list, I hope this one felt easier and much clearer to you. And if you found this video helpful, make sure to like, share, and subscribe to the channel for more such easy explanations. And don't forget to hit the bell icon so you don't miss the next video. where will we learn about the W circular linked list with the same simple style. So that's all about today. And thanks for watching. Keep learning and keep coding. Thank you.